Okay, we have here a well-known integral on the board. We've got 1 over square root of 1 minus x squared dx. Okay, now like I said, this is a well-known integral, and there's just a formula. You could just remember that the value of this integral is just going to be arc sine of x. But what I wanted to do is actually kind of just go into the details, just because I'm looking closer at the trig substitutions, and I just kind of want to look at how this actually works and where some of the issues are. So first, what I want to notice is because we're inside the square root here, and everything inside the square root needs to be positive, and we can't be dividing by 0. So that's going to tell us here that x needs to be less than 1, but it also needs to be greater than minus 1. So for this case where we have something minus x squared, the substitution we want to make is for sine. So I'll do the substitution. We want to do x equal to sine of t. And let's just get our derivative. So when I take the derivative, dx is just going to be equal to cosine t dt. Now the issue we have with this substitution is sine is not 1-to-1. It doesn't pass the horizontal line test. We can take a quick look at the graph of sine. I'll do my rough graph. Let's look at our graph of sine. Now looking at our graph here, sine of t, you'll notice it doesn't pass the horizontal line test. If we draw we can draw it anywhere we want, basically. Yeah, we can draw it anywhere we want. But if we just draw a horizontal line, here we've hit 2 points. And of course this graph goes infinitely in both directions. So clearly it's not 1-to-1 and we have a problem there. And so we can't really do this trig substitution unless we restrict the domain here on sine. So what we can do is just go from minus pi over 2 to pi over 2. So we can just kind of remove everything over here. And so doing it that way, you see that our substitution here is not actually for sine of t, it's just for this piece of sine of t. And that's important when we take the inverse. So let's kind of take this and come over here. So if I take arc sine on both sides of this, we're going to have arc sine of x here, and then this is going to be arc sine of t. And what we do here with arc sine of t is we cross that out and we just say this is t. But this only here works with this restriction on sine of t over here. Just looking at our graph of arc sine of t, you'll see it's that straight line. It's just t. If you go outside of minus pi over 2, you see that you'll get other values, and this is going to continue on like this and like this. So with these restrictions in place, we'll just put this down here. We can say that t equals to arc sine of x, and that's our substitution we're going to make. And we'll just include this restriction on t, that it's going to be less than pi over 2 and greater than minus pi over 2. Just by the definition, we could have less than or equal to here, greater than or equal to here. But we've already restricted our x, where x can't be 1, so then t can't be pi over 2 or minus pi over 2, because we'd be dividing by 0 on our integral. Okay, so now we can get back to our integral after all that explanation. So for our dx value, we'll just have this over here. So this is going to become cosine t dt. And then here in the denominator, we'll have the square root 1 minus x squared. So that's going to become x is sine t. So this is going to be 1 minus sine squared t. But on this here, we'll just use the identity that this is the same thing as cosine squared t. So then doing the rewrite on this, we'll have cosine t in the numerator. Then here we have the square root of cosine squared t, so this is going to become absolute value of cosine t. But then this is where we go back and look at how we've restricted t. It's going to be between minus pi over 2 to pi over 2. So that, if we look at our unit circle, just a really messy unit circle, if minus pi over 2 is here and pi over 2 is here. So this region we're looking at is going to be here and here. That's just going to be quadrants 1 and quadrants 4. But in this whole region, cosine is always positive. We get rid of our absolute value sign, but that's going to allow me to just cancel here and here. And so we're just integrating 1 dt. Integral of that, of course, is just going to give me t. We just back substitute, and we get our solution of arc sine of x plus c. So there you have it, our arc sine trig substitution. Thanks everyone for watching. Have a good day.